The National Electrical Code, or NEC, Section 250.148 addresses the connection of the equipment grounding conductor, or EGC, to a metal box. The question at hand is whether there's a specific code requirement mandating that the grounding screw used for this connection have a machine green finish. While there isn't a direct code reference explicitly defining the grounding screw's finish as machine green, it's crucial to understand the underlying intent of the code. The primary goal is to ensure a reliable and effective electrical connection between the EGC and the metal box. This connection is vital for providing a low impedance path for fault current, allowing overcurrent protective devices like circuit breakers or fuses to quickly clear a fault and minimize the risk of electrical shock or fire. A machine green finish on a grounding screw serves several important purposes. Firstly, the machining process creates a clean and smooth surface, which enhances the electrical contact between the EGC and the screw. This low resistance contact is essential for the proper functioning of the grounding system. Secondly, the green finish often indicates that the screw is specifically designed and listed for grounding purposes. This provides assurance that the screw meets the necessary standards for conductivity, corrosion resistance, and mechanical strength. The green color also serves as a visual identifier, helping electricians quickly recognize and select the correct screw for grounding applications. Thirdly, the finish helps protect the screw from corrosion, which can degrade the electrical connection over time. Corrosion can introduce resistance into the connection, hindering the flow of fault current and compromising the effectiveness of the grounding system. While reusing an MC clamp screw to fasten the EGC to a metal box might not be explicitly forbidden by the NEC, it is generally not recommended. MC clamp screws are primarily designed to secure metal clad, or MC, cable to boxes and enclosures. They may not possess the same level of electrical conductivity, corrosion resistance, or mechanical strength as dedicated grounding screws. Furthermore, using an MC clamped screw for grounding purposes can create confusion and potentially lead to improper installations. Electricians may not readily recognize the screw as a grounding point, increasing the risk of accidental disconnection or incorrect wiring. The NEC emphasizes the importance of using suitable grounding screws for connecting the EGC to a metal box. The term suitable implies that the screw must be of the appropriate size, type, and material for the intended application. It must also be capable of providing a secure and low-resistance electrical connection between the EGC and the box. Factors to consider when selecting a suitable grounding screw include the size of the EGC, the material of the box, and the environmental conditions. For example, in corrosive environments, a stainless steel grounding screw may be necessary to prevent corrosion and maintain a reliable connection. To reiterate, it is generally recommended to use a dedicated grounding screw with a machine green finish for connecting the EGC to a metal box. This practice helps ensure a proper electrical connection, prevents corrosion, and promotes safety. Furthermore, it aligns with the intent of the NEC to establish a reliable and effective grounding system. Here are some additional points to consider about grounding and bonding. 1. Grounding and bonding are essential for electrical safety. 2. Grounding provides a path for fault current to return to the source, allowing overcurrent protective devices to operate. 3. Bonding ensures that all metal parts in an electrical system are at the same potential, reducing the risk of electrical shock. 4. The NEC provides detailed requirements for grounding and bonding. 5. It is important to follow these requirements carefully to ensure electrical safety. 6. Proper grounding and bonding can help prevent electrical shock, fire, and equipment damage. 7. Grounding and bonding are not the same thing. 8. Grounding connects the electrical system to the earth. 9. Bonding connects metal parts of the electrical system together. 10. Both grounding and bonding are necessary for electrical safety. Here are some examples of grounding and bonding applications. Firstly, grounding the neutral conductor at the service entrance. Secondly, bonding metal water pipes to the electrical system. Thirdly, grounding metal equipment enclosures. Fourthly, bonding metal conduit to electrical boxes. Fifthly, grounding generators and transformers. Sixthly, bonding metal parts of appliances. Seventhly, grounding lightning protection systems. Eighthly, bonding metal structural steel in buildings. Ninthly, grounding computer systems. Tenthly, bonding cable trays and raceways. When selecting grounding and bonding equipment, it is essential to choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or UL, or Electrical Testing Laboratories, or ETL. This ensures that the equipment has been tested and meets the applicable safety standards. Additionally, it is important to select equipment that is compatible with the specific application and environmental conditions. For example, in corrosive environments, use grounding and bonding connectors made of corrosion-resistant materials. Furthermore, grounding electrode conductors should be sized according to NEC Table 250.66. Equipment grounding conductors should be sized according to NEC Table 250.122. Bonding jumpers should be sized according to NEC Section 250.102. Grounding electrodes must meet the requirements of NEC Section 250.52. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. Grounding connections must be made using approved methods such as exothermic welding, listed pressure connectors, or grounding screws. Avoid using methods that can loosen or corrode over time. Regularly inspect grounding and bonding connections to ensure that they are tight and free from corrosion. Retighten any loose connections and replace any corroded components. Keep grounding electrodes free from paint or other coatings that can interfere with their conductivity. In addition to the above recommendations, it is important to stay informed about the latest changes to the NEC and other relevant standards. Attend training courses and seminars to update your knowledge and skills. Consult with qualified electrical professionals when necessary to ensure that your grounding and bonding systems are safe and effective. Grounding and bonding are critical aspects of electrical safety, and it is essential to follow proper practices to protect people and property from electrical hazards. Remember to always consult the latest edition of the NEC and other applicable standards for specific requirements and guidance. If you are unsure about any aspect of grounding and bonding, seek the advice of a qualified electrical professional. Grounding is the process of connecting an electrical circuit or equipment to the earth. This provides a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices to operate and clear the fault. Bonding is the process of connecting together all metal parts of an electrical system that are likely to become energized. This ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The main purpose of grounding is to provide a low impedance path for fault current to flow back to the source. This allows overcurrent protective devices to operate and clear the fault, preventing electrical shock, fire, and equipment damage. The main purpose of bonding is to ensure that all metal parts of an electrical system are at the same electrical potential. This reduces the risk of electrical shock if a person comes into contact with two different metal parts that are at different potentials. Grounding is required for all electrical systems. Bonding is required for all metal parts of an electrical system that are likely to become energized. The NEC provides detailed requirements for grounding and bonding. It is important to follow these requirements carefully to ensure electrical safety. Here are some examples of grounding and bonding applications. Grounding the neutral conductor at the service entrance. Bonding metal water pipes to the electrical system. Grounding metal equipment enclosures. Bonding metal conduit to electrical boxes. Grounding generators and transformers. Bonding metal parts of appliances. Grounding lightning protection systems. Bonding metal structural steel in buildings. Grounding computer systems. Bonding cable trays and raceways. Proper grounding and bonding can help prevent electrical shock, fire, and equipment damage. Here are some additional considerations for grounding and bonding. Firstly, select grounding and bonding equipment that is listed and labeled by a recognized testing laboratory. Secondly, select equipment that is compatible with the specific application and environmental conditions. Thirdly, size grounding electrode conductors according to NEC Table 250.66. Fourthly, size equipment grounding conductors according to NEC Table 250.122. Fifthly, size bonding jumpers according to NEC Section 250.102. Sixthly, ensure that grounding electrodes meet the requirements of NEC Section 250.52. Seventhly, use approved methods for making grounding connections such as exothermic welding, listed pressure connectors, or grounding screws. Eighthly, avoid using methods that can loosen or corrode over time. Ninthly, regularly inspect grounding and bonding connections to ensure that they are tight and free from corrosion. Tenthly, tighten any loose connections and replace any corroded components. Keep grounding electrodes free from paint or other coatings that can interfere with their conductivity. Always consult the latest edition of the NEC and other applicable standards for specific requirements and guidance. If you are unsure about any aspect of grounding and bonding, seek the advice of a qualified electrical professional. The NEC Section 250 covers grounding and bonding requirements. Section 250.2 provides definitions for grounding and bonding. Section 250.4 specifies general requirements for grounding and bonding. Section 250.20 covers systems to be grounded. Section 250.24 covers grounding service supplied alternating current systems. Section 250.30 covers grounding separately derived alternating current systems. Section 250.50 covers grounding electrode systems. Section 250.52 specifies grounding electrodes. Section 250.64 covers grounding electrode conductor installation. Section 250.92 covers bonding other enclosures. Section 250.96 covers bonding metal water piping systems. Section 250.104 covers bonding of piping systems and exposed structural metal. Section 250.118 specifies types of equipment grounding conductors. Section 250.122 covers size of equipment grounding conductors. Section 250.130 covers equipment grounding conductor connections. Section 250.134 covers equipment fastened to support structure. Section 250.146 covers connecting receptacle grounding terminal to box. Section 250.148 covers continuity and attachment of equipment grounding conductors to boxes. Always refer to the latest edition of the NEC for the most up-to-date requirements and guidance on grounding and bonding. A thorough understanding of grounding and bonding principles is essential for electrical safety and compliance with the NEC. Neglecting proper grounding and bonding practices can result in serious electrical hazards, including electrical shock, fire, and equipment damage. Therefore, it is crucial for all electrical professionals and anyone working with electrical systems to prioritize grounding and bonding and to adhere to the requirements of the NEC and other applicable standards.